So guys, welcome to the webinar. I am Jayesh Halgekar and I'm a product specialist where I specialize in the range of the SolidWorks communication suite of products. And I hope you guys are keeping well and staying safe amid this crisis situation that we guys are at, hoping that this settles down quicker. So we'll get started, and good to see all of you here. To begin with, I'd like to introduce you to the SolidWorks innovation platform. So many of you guys here are, I'm guessing, SolidWorks users, but while we speak to most of our customers and the SolidWorks users, we tend to realize that not everyone is completely aware of the entire gamut of products that are available under this one ecosystem. So with SolidWorks, you do have your mechanical frontier where you can design for mechanical and you have got different modules under that. You've got options within SolidWorks in different set of licenses which can control and design, help you design electrical and electronics. We've got partner products with SolidWorks where they help in very specific applications, like we're talking about woodworking, where you've got an application that can help you design everything for your woodworking projects and communicate it all the way to your CAM and CNC machines. Similarly, there are other partner products that help in plant design, which include piping, isometrics, PNID diagrams, etc. So these are specific tools built on the SolidWorks platform. Now, once you've got your SolidWorks designs in place, you have an option or the solutions to basically validate these designs. You can test them for finite element analysis, structural analysis. You can, if your products involve a flow of fluids, you can simulate the flow using FlowSim. Again, there are different modules inside that for HVAC, for electrical control and cooling, as well as for plastic injection molding. So depending on your business, you can venture into any of these validation tools that are available. Now, all this data that you have also needs to be managed. It needs to be controlled. So you've got PDM, which is product data management, which is a solution available on the SolidWorks platform, allows you to make sure that you've got the right check-in, check-out process within the vault, the right access grants from the users, who's accessing it, who's controlling the CAD, who's viewing the CAD, etc., and as well as your revision controls. What I specialize is the communication suite of product, where we've got drawingless manufacturing, which is MBD, which we're going to take a deep dive into and see how it works. There's also a tool for quality assurance, which helps you automate your inspection procedures and your QA processes, especially with the ones who are focused towards the APQP processes, the PPAP processes in the manufacturing sector. This is a brilliant tool that can help you save all the time that you spend in the documentation of all of that. We've got a tool, a standalone tool, which is Composer, which leverages your 3D CAD data, your 3D designs and models, and uses that to create a whole range of technical collateral. So we're talking about high resolution images, vector graphics, animations, or even interactive content that can go directly onto your website, where users can interact with a model in real time, expand it, click around and find more details, and a lot more. We're doing I'm doing another webinar on Composer at the end of this week on Friday. So if you guys would like to explore this tool, feel free to register yourself for that webinar. And there's a tool called Visualize, which is used for photorealistic rendering. So it helps you create absolute real-time, high-resolution images and animations created right directly out of your SolidWorks CAD data. There are also tools which are partner products for SolidWorks, which is DriveWorks, which helps you completely automate your entire CPQ and designs. So it can allow users to work on a configurator, and a configured project can be then completely automated for creation of models, drawings, details, assemblies, quotations, commercial documents, and a lot more. We did a webinar on this yesterday, but if any of you who are just joining for today's webinar would like to know more about it, feel free to reach out to me, and I'm happy to take you through that. There's also a tool on the SolidWorks platform directly, which is called SolidWorks Cell, a relatively new product, which helps you directly publish your CAD files onto a web browser. Now, this is a software as a service, and it is not IT, it's not heavy on the IT infrastructure. So you can directly publish out your CAD files and configurations onto a private or a public browser, and you can engage a configurator for users to use, which also gives you plugins to engage it with your e-commerce platform, where users can directly make a configuration and purchase it by dropping it into the cart and complete the whole commercial transaction as well. It's got photorealistic rendering as an option that the users can actually have photorealism while they are configuring their your products on the website. So these are all different available solutions within the innovation platform. My job here is to just introduce what's available, and if any of these interest you, feel free to reach out to us and we'll get a specialist to engage with you on this. All right. Now, moving forward, today when we talk about CAD, everybody is well fascinated with the 3D printing aspect of things. We are living in an exciting age of manufacturing. All these emerging technologies like this 3D printing, big data analysis, we're talking artificial intelligence, connected machines, they are pushing manufacturing forward every day. Apart from these outrageous technological advancements like sending Teslas to Mars or challenging airline industries with concepts like hyperloops, there are some relatively moderate yet revolutionary paradigm shifts in manufacturing, which open the avenues for CAD as well. Now, 3D printing has been showing promise for many years now. It has been used for prototyping, iteration, and small-scale production, and it is already significant in usage, but we are now at the cusp of changing discrete manufacturing forever. But why is this important to us? Because this is a glimpse of where we are heading towards. This is more, and with this, more and more companies are venturing to adopt to trending manufacturing processes. It is necessary for us to offer solutions more than just SolidWorks design. So why are we talking about this really? This is because SolidWorks already has a tool to enable you to take a step forward to adopt this revolution, and you can automate manufacturing processes by reading digital designs directly, because that's what 3D printing would do. It doesn't use 2D drawings, right? How do we do this? We've got a solution called SolidWorks MBD. Now, SolidWorks MBD is basically a drawingless manufacturing solution. It's a tool that allows you to directly publish out your product manufacturing information and data directly into 3D formats, which we're talking about e-drawings and PDFs. Now, why do we want to look into this? Because the most common scenario today in the industry involves a heavy reliance on 2D drawings to manually create all this required production functions and documents. It is very disconnected with the design that you've developed in 3D already using CAD. And the production for this, it involves reading of the 2D drawings, which basically is talking about inefficiencies because there is human intervention involved, and conversions of all these file formats is anyways difficult to do with every design iteration. And not to mention of all the issues of ambiguity, misinterpretation, and the manufacturing errors that are possible out of this. So just communicating a design intent in formats like this, of course, we've been using it for centuries, but it's not something that has changed over time, right? It is going to be changing now with the use of the 3D formats which are now available. So the way forward is the model-based enterprise, which is an engineering strategy that aims to clarify all this design intent during the manufacturing process by using a 3D model-based solution, which is basically MBD. That includes all the product manufacturing information that we're talking about. So the datums, tolerances, dimensions, all the details that you would put in a 2D drawing can be done directly in 3D PDF. One of the biggest advantages of MBE is it replaces all that costly and inefficient paper-based systems. So the CAD model contains all the necessary information nowadays that while designing itself, we add all the production information, and it connects all the production processes, the inspection processes, and even supply chain. So basically what we're doing is we're heading towards the Industry 4.0 or the brilliant factories that we talk of. But how do we get there? MBD is the step forward. Now I'll open up a couple of examples to show you why we're talking about this and what does MBD enable as output files that you guys can consider. All right. So this is an output out of MBD. This is a PDF, which is a 3D PDF opened up from Adobe Acrobat Reader, free reader. And I have this gear plate here, which is a path file from SolidWorks, and I have all this information in this isometric view that I have, but it's within this preview window. It allows me to interact with this model in real time. Okay, I'm just going to have a quick check to see, to make sure that you guys are able to see my screen correctly. Yeah. All right. So with this, I've got this interactive format. You can have your top view, front views, all of that can be interacted with. And all these dimensions that we have here are not just simple dimensions. These are semantic PMI. They have a level of intelligence in it. So as I click on it, you can see it even cross highlights the feature that it is dimensioning against. So all of this can be in that format, which is directly published out of MBD. So there is no ambiguity that is involved here. If I'm confused about any particular thing, I click on this to make sure, all right, it's all the 6 flange holes which have got this dimension. So it highlights all of them directly for the user, right? You can also have different configurations. So let's say you've got, for the same gear plate, you've got two separate configurations and you want to replicate a view for both of them, one with a longer arm and thinner arm, and then the other than the default. You can copy annotation schemes directly from configuration to configuration. So you don't have to recreate anything. It'll even highlight the features which have changed within the new configuration, and then you can utilize that to add it within the view, annotation view that you have. More to this, where we're talking about this whole concept of single transmittal. That's the whole objective of this webinar today. You can see I have attached file formats in this: step files, original CAD files, DXFs. Whatever you guys use for your manufacturing and production, you can attach this within the 3D PDF and send it out as a single transmittal for your user. So with this, I can directly double click on this and download the file, and I have access to it. Now, if you're concerned about protection of your data, you also have options here within MBD to password protect data. So with that, you have control on that aspect of things. Now, this template that you have here within MBD, within this PDF, can be completely altered. So you can create a whole template based upon what you want as information to be published here. This information can be picked up directly from your custom properties in SolidWorks. You can have editable form fields as well. So let's say you send it to the supplier, the vendor, or to your manufacturing plant, and they want to know, okay, what is the surface finish, or what is the paint to be used. They can add this comment directly right here and probably send it back to you. Again, MBD is completely controlled within PDF, within PDM. So all the PDFs that are being spit out can be also version controlled using your PDM environment. More to this, if you've got assemblies, you can even have a detailed assembly with different views. So you can have cut sections, compound cross sections. You can have even exploded views with display states as well. More to that, you've got a BOM table as an add-in within the template itself. The BOM details are all picked up directly from your SolidWorks data. So this creates an interactive BOM table which cross-highlights components from the assembly onto the table, as well as the other way around. So if I click on any of the components, it even highlights on the BOM table directly as well. There are other options you can look into as well. So let's say within this particular view, there are certain dimensions which you'd like to add. You've got a 3D measurement tool within the PDF, which can allow you to, let's say, pick up center holes between. So if I want, I can just directly snap it between the two to find out the distance between them. Or you can even create section planes. So if you'd like to have a cross-sectional view, you can open up the property right here. You can engage cross sections on either y-axis or x-axis or z-axis, and then you can even offset the cutting plane to see a cut section view inside the PDF itself. So there are various options you can look at. You can control display states. You can control the way you have details appearing here. So you've got transparent bounding box, got a wireframe effects, basically different ways you can view this. So I'm just going to stick to solid, and yeah. All right, so you can have all these options that you can explore. I'm happy to share some PDFs with you at the end of this webinar, and you can explore them yourself. So let's have a quick look at how you need to create this sort of information and why should we do it. All right, so I'm going to open up SolidWorks now and bring it right in. And let's open up a file, which is this knuckle. All right, and I'm going to start to create all the product manufacturing information I need for this knuckle. Now, within SolidWorks, so MBD is an add-in inside SolidWorks, right? So here, what I'm going to do is I'm actually going to engage this tab here for MBD, and I'm going to utilize the auto dimension scheme from SolidWorks. With this, I'm going to just basically make a few checkboxes to identify this part for the software. So this part is a prismatic component. I'm going with geometric tolerancing, and I'm going with pattern dimensioning as linear. All I really need to is to pick up the primary datums. Now, all this information can be generated for me by the software. So primary datum, I'm just selecting this as my machine surface. Okay, for my secondary datum, I'm going to go with this, and tertiary datum, I'm going to go with this machine hole. So it's identified this as a compound hole for me automatically, and you have the options here to go with selective features. So if there are any selective dimensions you prefer to be a part of your information that you want to send forward for manufacturing, you can go and click on them and create all that PMI for you. But if you want the software to do it automatically, you can just go with all features, and I'm going to say, okay, hit. With this, you can see all the information has been populated, and it has already been assigned in different views. So the software has automatically decided what is the best suited view for any of these annotations, and it's also color coded this part for me. So the green highlights that all these features have enough information for me to send for manufacturing. It's all manufacturable. The yellow says it's underdefined. It needs a little more dimensioning details. Looking at the faces, it appears like there is basically angular dimension missing, which I can add directly. So I'm going to disengage this tolerance status, and I'm going to add directly. I'm going to add all the information that I'm missing here directly right here. So I use the location dimension, click on the faces, and you get your angular dimension. Same thing on the other face. All right, and here, if I then check my tolerance status, you can see that's green now. So it's got the information needed. So you can go ahead and whichever features you feel are not highlighted for green for manufacturing, if they are really required, you can then start to add the missing dimensions. But the software automatically would find out most of the information from the model and populate it for me. So now here you can see there are certain dimensions here, which is basically in the front view. I won't prefer them to be in the front view. I'd rather like them to be in the top view. You have the ability to directly toggle these dimensions and move them to any preferred view that you have. So you don't have to stick with whatever the software is just suggesting. You can make changes to that as well. So once that's done, what I'm going to do is I'm going to open my annotations, activate and reorient my top view. And you can see it has all the other dimensions as well, which the software has recognized. If you prefer, you can clean it up a little bit and save this out as a view, which you would use for your PDF. All right, this is good enough. Uncheck the tolerance status. Happy with the top view. I'm going to capture it. It asks you if you need annotations from any other views as well. Well, I'm just going to go with top for now. Happy with that. Same thing I can do is for the front view, activate, reorient. you've got certain dimensions. You can clean it up if you prefer. It's got the datum features. It's got this whole feature here. Maybe I'm going to move this one to the top. I'll tell you why I'm doing that as well very soon. So here, this is my view. I'm capturing this for my front, and same thing for the right. All right, so you've got 3 views immediately available for you to publish out directly. Now, these views can be dragged and dropped into a 2D drawing as well. If you prefer to still have 2D drawing with your 3D PDF, they can be just dragged and dropped into your drawing, and they will utilize that as a view as well. Now, moving back to my top view. All right, let's go back to the top view that I have here. And so this is the view that we had moved recently from another one. Now, this whole details that you see here, if I were to show those details, I'd probably do a cut section within our 2D drawing. Let's do just that here. So I'm going to create a new section view, and I'm going to save it out. So now you've got a new section view AA here. Now, what I'm going to do is I'm going to show feature dimensions. So if you don't want all your PMI, you want to leverage all your existing information that's already there in SolidWorks without you having to go and individually feature, select them to create the dimensions, you can use the feature dimensions. If I want to, add a view for the whole details, I can do just that right here. So what I'm going to do is I'm going to edit this section view, and I'm going to pick and choose which are the dimensions and details I want for this view. So I'm going to go with, it'll be best to actually pick up all the PMI that's in blue that is being generated by the software, because that is the semantic PMI. That will be the one which will be interactive in your 3D PDF, which cross highlights the details on the model. The feature dimensions, of course, are just for additional information, so they won't be a cross highlighting, but the PMI does. So you can create that same information using the DIM Expert tool from SolidWorks to have it all interactive. So I'm going to select these options here, which are better suited in this view. Yeah, I think I'm happy with all this information, and maybe this 30-degree angle. And that's about it. I'm saying okay. And now when I capture this 3D view, I'm going to say, okay, I just want the information from the section view and not the top view. Okay, so you've got a 30-degree angle, you've got all this information. You can clean it out if you prefer. And recenter this and capture view. So now you've got 2 section views. You can then edit one, you can delete the other if you don't prefer. So let's say all whole. So you've got all whole detail as well. Right, so you've got your right, you've got a top, you've got your oil hole. Maybe we don't need this. Okay, so now this is as easy as capturing this information. So all these views are now available. Now you've got an option here is to basically edit a 3D PDF template. So there are a whole range of existing templates which are available inside MBD, which you can utilize. But if you would like to make a template from scratch, you have the options to do that as well. So you can open up the template editor and edit any one of them, or you can browse any of the existing options and then pick up any one of the templates from that. So if I do that, it's just going to basically take off all the details. All right, let's do it anyways. So here you can see these are all the different templates I have. I've created some for different customers that are using MBD, but I'm just going to go with the one which I've created here. I'm happy with this selection, so I'm going to say okay. Now, from here, it starts to ask you information that you would like to have included in your PDF. So it gives you a little preview of what you're going to be expecting. So it's just taken the top view, the first view. I also want to have the front, the right, and the oil hole as a part of those thumbnails. Custom properties, again, you can pick up all this information. So you've got the drawing number. You can then pick up the part number details. So the part number. So you can see all that information is now getting filled up right here in my template. I'm just linking back the right information from SolidWorks custom properties to the template. Some of it is automatically identified, doing a direct check on the name. So as it matches, it utilizes that information directly to feed it in. Now, you can even attach files. So I can attach probably any other files that I have. Let's do that in a bit because I'm going to add some other details as well. So here going forward, then you've got your independent viewports. So this is basically a viewport that I have created on my second sheet of that PDF. So you can have multi-sheet PDFs as well. So in that view, I would not want the front. Probably I'd prefer the oil hole. Then again, you've got your custom properties. So here you can pick up your author for the detail or the check date, depends what you want to add in. And once you've got all your information that you need, all you need to do is click OK, and it'll publish out the 3D PDF. But I'm not going to do that just yet, because what I'm going to do is I'm going to show you how we can integrate inspection. Now, what is inspection? Let's have a quick look into that. So I'm just going back to my PowerPoint slideshow. So the reason why we were talking about MBD in the first place was because the whole concept of this is not about creating 3D PDFs and e-drawings. It is about the time that you'd save in creating 2D drawings. You saw we used the 3D model. We leveraged the information from the 3D model to create views, which, don't get me wrong, are still 2D views when I'm clicking on the thumbnails. Because if I open up that PDF, those are still 2D views. If I print it out, it's still a 2D drawing. But the 3D PDFs gives me the interactive ability for my user to avoid any sort of ambiguity or misinterpretation from what he would probably get with a 2D drawing. In the 3D formats, they have actually done a test to prove this out. So this was a test done by the National Institute of Standard and Technology in the US, and they actually tested out the conventional method of using 2D drawings by building a product from scratch, designing it, and then manufacturing it all the way. They tried it in 3 different ways. One was with full annotation using MBD, and there was hybrid annotations as well as reduced annotation. So looking at all this, what they found was something that took them the conventional method of developing, which took them 83 hours. They were managing to do that in 18 hours just using MBD. So that's the kind of time saving we're talking about, and this is why we are proposing a tool like this. Now, when we talk about this to most of our customers, this is the most common objection we get. It's radical change. We are not ready for that yet. We've been using 2D drawings. Our vendors won't be able to read 3D PDFs. Well, this has been an excuse for a lot of different things that we are using today. Okay, it includes our use of 3D softwares. The world wasn't ready for 3D software. The world wasn't ready for SolidWorks at all. But today, it's the majorly used tool for design. Talking about our regular usage, phones, mobile phones, the App Store. The world wasn't ready any time for that. Once launched, everybody got used to it, got hooked to it, and now they can't live without it. So that's how the same concept flows right here. Okay, so there's no point where you're doing everything in 3D, you're breaking the third dimension, going back to 2D to just communicate all the design that you've done in 3D. It's basically taking a step back to the way you're doing. And the Department of the Defense of the US was not ready as well. So this concept actually started from there. Okay, they built an armored tank which had 1 million components inside it. They had massive sub-assemblies, assemblies. The whole tank weighed over 2 tons. So they had to have all the documentation in hard copies and formats for every single component of that armored vehicle. And guess what weighed more? Was it the documentation or the armored vehicle? So this was the joke that was brought about from them. They put it over to the software developers for CAD, saying we need a solution for this. And this was basically the birth of model-based definition. So today, many of the suppliers of the defense of automotive giants are kind of making it mandatory, or their preferred suppliers, to follow the model-based approach than using 2D drawings. So it is changing over time. And again, this is all integrated within PDM. So it's all of that can be configured within the PDM environment. Now, talking about inspection, inspection again is another add-on inside SolidWorks. So just like an MBD, right next to it was inspection, and what it does is it helps you basically make a seamless flow for your QA processes. So when you're following a QA process with industry standards, there are a certain set of reportings that you need to do. SolidWorks Inspection will automate all of that for you. It can look up different versions, compare them, and it can manage the revisions that are being created to add the inspection details. You can connect it directly to machines like the CMM for providing all the information on the inspection processes, the readings. You can have digital calipers and verniers as well, fed data directly to your inspection projects. Now, this is CAD agnostic. Basically, what it does is inspection works as an add-in as well as a standalone. So if your QA division or your inspection team is at the factory location where they don't have SolidWorks, they can still have SolidWorks Inspection working as a standalone. And it basically can read PDFs and TIFFs, which are 2D drawings, and then you can have all that information captured directly into an inspection project by just snippets. I'll show you how. So with this, it's basically making it a lot easier and quicker for your inspection processes. So what it does is SolidWorks Inspection as an add-on, you'll have all your information from MBD generated for your component in 3D files. Inspection will directly balloon all those dimensions that you need to be inspected, as well as it will directly publish out a drawing with the balloons or a 3D PDF with the balloons, as well as an Excel sheet, which would be the industry formats, which will have all the individual line items for the dimensions to be measured, their maximum tolerance levels, and a field for you to input the readings of your inspection, which will again be conditional formatted to show you if it's in and out of specs as well. Okay, so with that, you've got options of automatic ballooning. So once you've got your information in SolidWorks, it identifies all the required details and it creates the balloons for you with a whole detailed inspection project. The first article inspection packages, it can reduce all the time that you would spend by individually and manually entering all this data in an Excel sheet by 90%, because it does it in seconds for you. When it works as a standalone, it's got a feature called the optical character recognition. So what it does is it's literally like a snippet tool. As you take a snapshot of a dimension, it automatically identifies the dimension, category, and type. It'll also identify the maximum tolerance level and add the upper and lower limit to it, and gives you a line item for you to feed your information of your reading from the inspection project directly right here. So like I said, it also has revision control. So if you've made changes and got a new version, it will compare the two documents to see which are the dimensions that have changed and does it need to have a balloon added to it to inspect it. You can connect it directly to digital verniers to have the readings fed directly into your inspection project by a click. You can even download files from your CMM to load them up into your inspection project, and then it'll reference the required nominal values, upper lower limit, and identify what is the reading and for which dimension is it. So it'll immediately create a column for the readings to show if they are in and out of spec. So if all the dimensions are in specs, it'll highlight them on the drawing alongside the balloon as well to show them they're all green. If it's not in spec, it'll highlight them as red. So it's pretty seamless in the way it goes, and it's very it basically color codes and gives a very good representation of what needs to be checked after the inspection. All right, so jumping back into our project here, we've got the views that we've created. If I want to create inspection details for some of these dimensions, for example, this hole right here, I'm going to allow a parenthesis to it to show that this is an inspection dimension. Same thing, let's say, okay, I need an inspection for this dimension. Maybe let's go with this one. So we go with certain dimensions in different views. So here I'm going to add a parenthesis to this one. And in the top view, we're going to go with, for this chamfer right here. and maybe this as a dimension. Okay, so I've marked parentheses to the dimensions we want inspected, and we are going to create an inspection report for this. So I'm opening up my SolidWorks inspection add-on right here. I'm going to start with a new inspection project. You've got different templates available based upon the industry formats you guys follow, ISO, ANSI, the various programs. You can add more if you prefer, or you can utilize the ones available. So I'm going to go with that part name. So here it's just giving me all that information. So for the part name, I'm just going to go with knuckle. Part number, oops, it's just putting things onto my other screen for now. Okay, so I can keep going on with that. Part revision, okay, this is taking time. So I'm going to skip all the other details. You can even add vendors right here. So let's say if you've got a vendor list available for this component, you can pick up those details by adding, if you're linked it to the system. Now I'm going to go with automatic ballooning. You can go with manual ballooning by clicking on individual dimensions to add balloons on them. But you can then set up your sampling size to see how many of them do you want inspected as a part of your sampling batch. What's the level and type? How tight do you want the inspection to be? All right, going forward, I'm going to go with inspection only. So the ones which you've marked with parentheses, we want them to be ballooned. You can again have different options on checkboxes on what you want included and excluded as a part of this. If you want subcategories within a single reading, saying, okay, needs to be checked for 1, 2, and 3, you can create that kind of categorization as well. You can pick up what is the tolerance settings type that you want. So you want to go by precision, by range. I'm just going to go with the defaults, and I'm going to say okay. And that's it. The software automatically will start to generate out the balloons for the required dimensions that we have. So it's created the balloons for those dimensions. And with that, you can see all those individual balloons. So you can see it's created for a particular dimension, which is the R10. It is wherever the radius needs to be checked. It's created a 4.1234 for it. So all your readings for all those chamfers can be added in. So you've got this inspection project created. I can directly export this to an Excel sheet. So for example, here, if I can even add my inspection process. So, okay, whole call out. All right, this is the whole. You can even add what is the way I'm going to reference this. So this is marked as balloon 7, which is circle. Now let's say this is a key inspection characteristic that I want. I can mark it as key, so it will change the ballooning for me to highlight it as a key characteristic. You can even pick up what is the operation. So what is the operation of this hole? It's going to be a drilling operation, and then you can pick up the method of your inspection. So I'm going to measure this, let's say, with digital calipers. So you can pick up all that information, and with that, all this information is fed into your Excel sheet, which you would utilize for inspecting this project. So this part, now if I just click on export to Excel, okay, I can, you can, like I said, you can add different templates. You've got AS9102, PPAB, APQP, whatever you need. So I'm just going to go with AS9102, open, multi-sheets, and I'm going to say, okay. You can then allow it to be published out. So knuckle webinar 2204. And if I open up that Excel sheet, okay, didn't seem to save it out yet. So while I get that, let me explain how I did this now. So, okay, here it is. So this is the first article inspection which has been created. It's got 3 forms based upon industry standard formats. So it's got my knuckle details, my part number. If I go to form 2, this gives all my product accountability. And here is where we've added the details for that individual characteristic that we've identified and ballooned. So this has got automatically printed out for me. All I really need to do is go to my inspection and start adding the details. So if my inspection is out of spec, it'll highlight it as red. But if it is, 9.85, and then it is green, right? So it's all conditional formatted for me. Okay, just close this. Yeah, all right, save this. And just going back to my SolidWorks. So here, what I can do is I can jump back to my MBD and going back to my publish to 3D PDF. Now it's got all the balloons as well included here. If I go back to my publish to PDF, I can then pick up again on the views that I want. And custom property fields, again, you can, so project number. Yep. And then here within the attachments, I can attach now the webinar file that we've created right here. So that is a part of it. You can even have an original CAD file if you prefer. So I'm just going to go with webinar open, and then of course you can add more files. So if you want to attach to original CAD file, open. So you can add that as well. Moving forward, independent viewport, we're going to go with the oil hole. And you can even attach the step 242 file format. Now the step 242, I'll explain what it is in a bit, but it's an automatic check-in box. With that, I can get a 242 file format, which is readable by most different CAM programs as well. So all this information that we've created via MBD can be read directly. All right, and now I'm going to hit publish. So knuckle. That's it. All you need to do is hit save. You've also got options here to publish to eDrawing. So if you want an eDrawing file, you can do that as well. Again, there are different other options if you want to add details about bombs, about any other tables, design tables. Even if you want to have, if you've got sheet metal components and you want to have all the information about the bend tables and bend lines, and all of that can be populated within MBD to have a 3D view of it. Yep, so what I'm going to do is I'm just going to open up our saved out file. I forgot to do the settings for the text size, so it's basically not got the right text size for me, but that's fine. So what you basically have here is all that information with the balloons added into this program. So for my inspection team, I can directly send them the 3D PDF, and they can actually check out the details for this oil hole as well to see, okay, if they've had a measurement for any of these details. Same thing, this is my key characteristic. So this is the holes that we need to measure for the key characteristics and feed it into my inspection project. Now, how do I get access to my template for inspection? This is it. This is the Excel file which it has spit out for me. So I can directly double click on this and it will download the inspection sheet for my user to utilize. So they've got the balloon 3D PDF and they've got the inspection project for them to start working on the QA process. So this is an output that you have directly from MBD. Of course, I forgot to do the settings for the text size, but that's fine. Eventually, you do get a very detailed 3D output from using SolidWorks MBD plus inspection as an integration solution. So where are we talking about application? It's here. Talking about a typical manufacturing company which has got both manufacturing and inspection as a part of it. MBD will provide the 3D PDF with the PMI for manufacturing. Product once manufactured is sent for inspection. The inspection process involves utilization of the inspection project, the Excel sheet, to feed the data in. But with that, they would need the balloon drawings, but instead of having balloon 2D drawings, you can have a balloon 3D PDF with all the PMI, which is interactive, which can be used by both these departments together. All of this can be controlled in the PDM environment, so it's all revision and version controlled. But the main feature of going towards the model-based enterprise is the use of the STEP 242 file format, which is semantic PMI, which is machine and human readable. So there's already some of the CAM programs from SolidWorks which are able to read out directly the STEP 242 file format to create the NC code using the post processor directly and actually cut out parts using it. There are also a certain set of CMMs which are able to read the STEP 242 and then create an inspection procedure. So there have been some test cases which have been published for this, but that opens up the whole realm of going towards the model-based enterprise, because here you don't really need any human intervention. All of this can be directly automated using one file format, which MBD has created for you. So this is where we promote the use of the tools from SolidWorks, which are MBD and Inspection, as an integrated workflow for you. So that's about it from my end. I hope you guys have enjoyed this webinar. And if you've got any questions, feel free to put it down here in the chat, and I'm happy to take questions right now if you prefer, or else you can reach out to me directly on this email, and I'm happy to address your questions as well. Okay, I've got a few questions here. Can you include non-SolidWorks outputs in the 3D PDF? Well, you can't do it in the 3D PDF because we open up MBD as an add-in inside SolidWorks. So it will utilize your 3D CAD from SolidWorks to generate the content out from there. Can the publish from 3D PDF tool also automatically insert STEP IGS into the same output file? Yes, you can attach any file format that you can. So it's literally just gives you a checkbox to pick up what sort of files you want picked up from there. What software does the end user need to view the files? Is it just a PDF reader with 3D capability? Just an Adobe Acrobat Reader DC. This is what we opened up right here. So even if they don't have SolidWorks, the Adobe Acrobat Reader on the PC is good enough for them to view your 3D PDFs. In the NIST study, did they find any change, improvement or not in accuracy or errors in manufacturing? They did find quite a few. I'm happy to share that whole white paper with you. It's already published online. So even if you just Google NIST, MBD, SolidWorks, it will give you this result. But I can send this across to you as well. Of course, this study was done almost 3 years ago. MBD has evolved quite a lot from then. So there's a lot more additional features that MBD does today compared to what it did three years ago. Is it possible to get an example of a 3D PDF output? Absolutely. I'm happy to send you a couple of 3D PDFs. There are different options available. I've got some 3D PDFs which are for sheet metal, for welded components, for assemblies, as well as what we saw today. So I'm happy to share these files with you as well. Can we get a file or two to show manufacturing and get the feedback? Sure, I can send some 3D PDFs to you, run them through your teams and see get their feedback, see how how comfortable are they to receive files like this, and yeah, you can have their feedback on that. But like I said, there are different ways on how you can approach this. So, for example, a company like GE, which is a giant, who are one of the forefront runners in smart factories, they use something called pseudo drawings. Now they've had workstations or departments which were not feasible to have screens or computers for them to interact with 3D models, but they did not let that defer them from their idea of using the whole 3D interface. So what they did is they actually had 3D PDFs as their primary data of information, but for these specific departments, they managed to just give them the printouts of the 3D PDFs, which eventually are just 2D drawings. If you print out the 3D PDF, the views are 2D. So these drawings were used by them. In the interim, they worked on different concepts to get them working and functional on 3D. But then after that, eventually all the handprint and paper-based versions were all eliminated, and it was all run through 3D interfaces. So we've got a lot of customers across Australia as well. Many of them are using MBD with workstations having screens on the shop floor, and they're either using e-drawings or 3D PDFs for them to interact with the model to make sure that they're getting the right information. So even in sheet metal, to make sure that they don't miss out on the wrong side of the bend, they're using MBD to make sure that the operator at the machine is bending the components on the right side, and there's no misinterpretation using 2D drawing. So we've got a variety of case studies on how people have managed to utilize MBD. All right, so we don't have any further questions. I hope I've been able to answer your questions here, but if not, feel free to reach out to me over email, and we can have a chat about it as well. So thank you guys for attending the webinar. I really appreciate your interest, and take care. Thank you. Bye.